Oops, I need a piece of paper there. So section 3.6, more curve sketching. And so now what I want to do is take things from so I'll call it CurveSketching02, I guess. Take things from the first video and string them together. So, for instance, suppose I have some intervals, and I'm just told, and we'll start with knowing all three things. So we'll just do maybe 3 intervals. So from minus infinity to -3, we're told that f is greater than 0. We're told that f prime is less than 0. And we're told that f double prime is greater than 0. And then on the interval from -3 to 2, we're told that f is less than 0, and f prime is less than 0, and f double prime is greater than 0. And then we're told that on the interval from 2 to infinity, f is still negative. F prime is now positive, and we'll keep f double prime as positive. Okay, so now what I want to do is try to sketch that thing, and I'll just go here to -3 and to 2, and I just kind of look at it and I say, well, f is positive over here. F is positive, but the function's decreasing, concave up. So decreasing concave up, kind of like that. Then it is negative, decreasing, concave up. So same basic shape, but now negative. And then still the function's negative, increasing, concave up. So now this says 2 to infinity. As I draw that, right, it's negative, increasing, concave up. Maybe, I look at something like that and I think, well, that probably can't go all the way to infinity like that, right, because it looks like it would head out like that. So, this is the best I can do with the information I have, though. And so then, now, if we assume f is defined everywhere, the best I can do with this picture is kind of fill it in a little better. I'll make 0 at -3. I'll get a minimum here at 2. And then I'll go up like this, and since I really don't know that the function could keep going like this, I'm just going to stop and let somebody else decide what must be going on. Okay, but the point is, I haven't screwed anything up as far as what this says, right? I don't believe the function would probably do this all the way out to a positive infinity just because of the way the shape's going, but I don't have any more information than that, and I can at least draw that much. I've kept f negative, the derivative is positive, and it is concave up, and so I did that. And all the others are fine. The function here is positive, decreasing, concave up. Function here is inside here is negative, decreasing, concave up. So I hit them all. I got them all. and I got it that way. Okay, so again, you know, what else could happen? Well, more likely, let's say I had those same two things again. So minus infinity to minus 3, minus 3 to 2, and then I'll go 2 to infinity. The first two will be exactly like they were before, so f is greater than 0, f prime was less than 0, f double prime was greater than 0, then f was less than 0, but f prime was still less than 0, and f double prime was greater than 0. And then suppose I have f is less than 0, f prime is still less than 0, and then f double prime is less than 0. Okay, what happens with that? Well, there's the -3, there's -2. Well, I know nothing changed in this part, so I know I still have that. And then after that, the function's negative, it's decreasing, but it's concave down, and so it would do something like that. Now, the way I drew this, it looks like possibly the slope is 0 there. That's okay. We didn't say anything about the slope at 2. We said in between, and so, you know, what I did there is fine. But that, you know, so the first two parts are the same, but the second part looks a little more likely of something I could really draw and could really do. Okay, so that's this idea. Now, I can add in some other things, you know, so for instance, another example could simply be, I don't give you all the information on every interval, but I give you some other information. I could say, oh, from like minus infinity to 1, I could tell you that f is greater than 0, and I could tell you that f double prime is also greater than 0, but not tell you anything about the derivative. Then I could also tell you that f at 1 is 2, and f prime at 1 is equal to 0. Okay, and then I could give you the interval from 1 to infinity, and maybe tell you that f is, try to make something that kind of works here. So since we're positive, I guess we'll have to keep it positive. Well, we don't have to. Well, let's change that. Let's make it negative. F is negative, and f double prime is negative. Okay, what could I draw that would fit all these things? Well, okay, there's 1, and I definitely need to go here to 2 and place the function right there, and I need to give it a derivative of 0. Now, what could that mean given these other things? Because notice f is less than 0 as soon as I get over here to the right side of 1. And so actually, you know, what this probably means is we can talk about one-sided limits, so we can talk about one-sided derivatives. As I look at this, f is positive to the left of 1 and concave up, but the derivative at 1 is 0. I guess, I could draw something like that. See, I didn't say anything about the derivative up here, so having it decrease is fine. But then I have it flatten out here at 1. And that's kind of the best I could do, because in some ways that doesn't exactly make sense, given that I said, okay, f is negative once I get over here, so maybe I'll put a open circle, and then it's concave down, so maybe I'll do something like that, and that would be my function. Okay, this is a little questionable, just like this was a little questionable. Or actually, concave up probably wasn't such a, well, yeah, concave up probably wasn't such a horrible thing. I could have maybe kept it decreasing, but then that would have been the same thing as up here. But, there was something between those two things that kind of looked wrong there. Or possibly the wrong thing was this needed a discontinuity and it needed to start positive and, kind of go up like that. That would have made sense, right? So again, I'm given a list and I try to do the best I can. The second one worked out great. This, yeah, everything fits together. This one, something's a little funky with that derivative because it seems like it would only be one-sided. But we can have one-sided limits and all that. It's just, is that what's really going on? But so you just try to take care of the sections and then try to meet them up. So now we're going to say, oh, you have a continuous function. Okay, that's information. So for instance, this one up here, not continuous. So it's continuous. And we're told that on from minus infinity to -5, right? We know that f is, say, negative. Okay, f prime is positive, and f double prime is negative. Okay, so we have that. We then can go from, say, -5 to, we'll go to 3, I guess. And maybe f is greater than 0 in that area. F prime is greater than 0, and f double prime is less than 0. Then maybe from 3 to 7, f is greater than 0. F prime is less than 0, and f double prime is less than 0. And then maybe 8 to infinity, f is greater than 0, f prime is less than 0, and f double prime is greater than 0. And then let's toss in. So we've said it's continuous. Well, sure, that's all we'll go with. So when I go to draw this thing, -5, what do we go to? 3. Oh, and I said 8. That should say 7. I did want to make those match. So we go to 3 and 7. And as we look at this, so from minus infinity to -5, the function is negative, but it's increasing and concave down. So the function was negative, increasing, and concave down. Looks kind of like that. And notice I don't worry about where it goes to. I just know it's negative. Then the only thing that changes from 5 to 3 is the function's now positive. Okay, so now it's up here. Then from 3 to 7, the function's still positive. It's still concave down, but now it's decreasing. So there's a piece of a function that's positive and concave down, but decreasing. And then finally at 7, it's greater than 0, but still decreasing. So those two are the same, but now the concavity is up, and so it looks like this. Okay, so I need to make this thing continuous. I can do that. So I'll end up having to erase a little bit, but I can just kind of come up here, come up here through the 5. I'm going to have a relative max at 3, and then it comes down, and I'll almost get where I could have joined that, but now you see I must have an inflection point at x equals 7, and so I'll get rid of some of this stuff that I don't need, and there we go. And see, I could ask, you know, I could say, okay, here's what we know. Could you tell me relative extrema and inflection points? Well, sort of, not exactly. What I can tell you is a relative max at x equals 3. I can't tell you the value. I could tell you that f of 3 is greater than 0, but that's the best I can tell you. And then I could tell you an inflection point at x equals 7. And again, I could tell you, well, I do know f of 7 is greater than 0, but that's all I know. I don't know what its value is. Okay? So I could give you this kind of information and then ask you to determine not only kind of what it looks like that way, but then give me some information about things we've been studying, relative max and min and inflection points. Okay, so there we have more on curve sketching.